This is Algebra Lesson 5-6, Parallel and Perpendicular Lines. Parallel lines are two or more lines that lie in the same plane but never intersect. Think of railroad tracks. Railroad tracks are parallel lines. If they didn't stay the exact same distance apart and they intersected, we'd have a lot of derailed trains. Perpendicular lines are two or more lines that lie in the same plane and intersect at right angles. Okay, that would be like a wall to a ceiling or a wall to a floor. It intersects at a right angle, and the symbol for a right angle is an upside down capital T. Like that. A negative reciprocal, sometimes referred to as an opposite reciprocal, is a number of the form of negative b over a, where a divided by b is a non-zero rational number. The product of a number and its negative reciprocal is -1. For example, if I told you I had a number 2/3, its negative reciprocal would be -3/2, because 2/3 times -3/2 will equal -1. Any whole number, like 3, its negative or opposite reciprocal would be -1/3. So as you can clearly see, if you take a number and its opposite reciprocal, you get the product of -1 when you multiply them together. Now let's take a look at the following two equations. We have y equals 1/2 x minus 1 and y equals 1/2 x plus 3. We're going to graph both of these equations on the same x and y axis. And to make this easy, I'm going to label one of the equations 1, and I'm going to put it in purple, and I'm going to label the second equation 2, and I'm going to put it in green. Okay, so if I was to graph equation number 1, first thing I'm going to do is figure out where its y-intercept is. Its y-intercept is at -1, so I'm going to begin there. And the slope is 1/2, so up 1/2, up 1/2. I will graph that line using my handy-dandy straight edge. And I will label my equation. This is equation number 1. The second equation, y equals 1/2 x plus 3, has a y-intercept at 3, and it has a slope of 1/2, so up 1/2, up 1/2, up 1/2. Get my handy-dandy straight edge there, connect these 2 points, and we can label this equation number 2. And you can see that these lines don't appear like they're ever going to cross. So if it says, what do you notice about the two lines? It appears they will never cross. So if they will never cross, it appears that they are parallel. Then it says, what do you notice about their slopes? Well, if you look at the slope of the first equation, okay, problem number 1 had a slope of 1/2. Equation number 2 had a slope of 1/2. So if we were to graph a bunch more lines, we would soon realize that if two lines have the same slope but a different y-intercept, as these two equations do, they will end up to be parallel lines. Okay? This leads to a very important concept that we're going to be talking about today, and that is the slope of parallel lines. Two or more non-vertical lines are parallel if they have the same slope and a different y-intercept. Any two vertical lines are parallel if they have different x-intercepts. Okay? So two or more non-vertical lines are parallel if they have the same slope and a different y-intercept. If they have the same y-intercept, they'd be the same line. And any two vertical lines are parallel if they have different y-intercepts. So you can use this fact to be able to write equations of lines that are parallel to other lines and to be able to determine if lines are parallel. So let's take a look at this first question here. It says, writing an equation of a parallel line. Write an equation for the line in slope-intercept form that contains the point -2, 3, and is parallel to y equals 5/2 x minus 4. So the first thing I'm going to do is I'm going to pay attention to the fact that it's got to be parallel to this equation right here. The slope of that equation is 5/2, which means my slope of the line I'm going to have also has the exact same slope. And I'm going to go through point -2, 3. So if I use the point slope form of the equation, y minus y1 equals m times x minus x1, where, if you remember, this is x1, this is y1, I'm going to plug the numbers in. So I have y minus 3 equals 5/2 parentheses x minus a minus 2 is a plus 2. Now I'm going to distribute, because I have to put this in y equals form, because it asked for slope-intercept, not point-slope form. So y minus 3 equals 5/2 x. 5/2 times 2 is equal to just 5. Solve for y by adding 3 to both sides. And the equation of the line that goes through the point -2, 3 and has the same slope as y equals 5/2 x minus 4 is y equals 5/2 x plus 8. So you can see how you can write the equation of a line that is parallel to another line as long as you know what the slope of one of the lines is. Let's take a look at another example. Write an equation in slope-intercept form for the line that contains 0, 6 and is parallel to y minus 3x equals 4. Now, most people would look at this and go, oh, the slope is -3, but you have to pay attention to the fact that y minus 3x equals 4 is not written in slope-intercept form. So we have to first get this equation into slope-intercept form. So I need to add my 3x to both sides. So that would give me y equals 3x plus 4. Now I know that my slope is 3, and I'm going to go through the point 0, 6. Using the equation y minus y1 equals m times x minus x1 again, I will start plugging my numbers in. So y minus 6 equals 3 parentheses x minus 0. So y minus 6 equals 3x plus 0. Add 6 to both sides. And y equals 3x plus 6. So the equation of the line in slope-intercept form that is parallel to y minus 3x equals 4 and goes through the point 0, 6 is y equals 3x plus 6. Now, let's take a look at two different lines here. Now I'm going to graph the line y equals -1/4 x minus 1 and y equals 4x plus 2. So again, I'm going to label them as 1 and 2. This is equation 1, and I'll do them in different colors just because it's easier to see them. So in this first equation, my y-intercept is -1, so I'll begin there. And my slope is -1/4, so from -1, I'm going to go down 1 to the right 4. And from that point, down 1 to the right 4. Use my handy-dandy straight edge to get my points. Straighten out my line because I did a terrible job of graphing that one. So this is equation number 1. Equation number 2, y equals 4x plus 2. I will go up to 2, and my slope is 4 over 1, so up 4, 1, 2, 3, 4, over 1, up 4, 1, 2, 3, 4, to the right 1. Again, use my handy-dandy straight edge. Hopefully I'll do a better job drawing my line this time. Oh, much better. This is equation number 2. And we see our two lines. If you notice, it says, what do you notice about the two lines? They definitely cross, don't they? The blue line and the green line cross. And it appears that they cross at right angles. Okay. If you remember, a right angle is an angle of 90 degrees. So it appears that this blue line and green line intersect at a 90-degree angle. So let's take a look at their slopes. In equation number 1, the slope was negative 1/4. And in equation number 2, the slope was positive 4. If I look at these, negative 1/4 times positive 4 over 1 is equal to negative 1, which means these are negative reciprocal slopes or opposite reciprocal slopes, which means that their slopes are opposite reciprocals. I probably will refer to it as negative reciprocals more often than opposite reciprocals, but I think most people understand opposite reciprocals a little bit better. This leads to a very, very important concept that deals with perpendicular lines, and that is the slopes of perpendicular lines. If two lines are perpendicular, if the product of their slopes is negative 1, a vertical line and a horizontal line are always perpendicular. So we can now classify things. We can be given several lines and we can tell whether or not they're parallel, perpendicular, or neither. So let's take a look at a couple of examples here. It says, determine whether the following are parallel, perpendicular, or neither. And notice how to spell parallel and perpendicular, please. It's always annoying to me when people can't spell parallel or perpendicular. So pay attention to the spelling. If we look at this first problem here, the first equation, y equals 3x minus 1, the slope of that is 3. And the second equation here, y equals negative 1/3 x plus 2, that slope here is negative 1/3. Another way of writing the slope of 3 is writing it as 3 over 1. So we can clearly see that these numbers, one's positive, one's negative, so they're opposites, and they're reciprocals of each other. So if they're opposite reciprocals, that means these are perpendicular lines. Okay, P-E-R-P-E-N, perpendicular, not perpendicular. So these are perpendicular. Number 2, y equals 2x plus 5. So the slope here is equal to 2. And over here, 2x plus y equals negative 4. I have to write this in y equals form first. So I will get y equals negative 2x minus 4. So the slope here is negative 2. Now these are opposites, but they're not opposite reciprocals. 2 and negative 2 are opposite of each other, but they're not reciprocals of each other. Therefore, this would be neither. And we look at problem number 3 here. Y equals negative 2/3 x minus 1, and 2x plus 3y equals 6. Well, in this first problem here, your slope is negative 2/3. In my second problem, I have to solve it for y in order to determine what my slope is. So 3y will equal negative 2x plus 6. Because I have to subtract my 2x, just in case you didn't get that little point that I did. Then I'm going to divide by 3. Divide everything by 3. Show that separately, otherwise you're going to forget to divide something by 3. So y is going to equal negative 2/3 x plus 2. Okay, this line has a slope of negative 2/3. The last thing I should do is look and make sure they have different y-intercepts. Y-intercept here is negative 1, y-intercept here is positive 2, so these are definitely parallel. If they would have the same y-intercept, they would be the same line, and therefore they would not be parallel or perpendicular or neither. They would just be one line. Okay, since you can write equations of lines that are parallel to each other if you have a slope and a point, you can also do the same thing if you have a slope and a point for perpendicular lines. So if we're going to write an equation of a perpendicular line that contains the point 1, 8 and is perpendicular to y equals 3/4 x plus 1. So the first thing we have to do is look at our equation and figure out what our slope is. In this particular equation, my slope is 3/4. I don't need the regular slope, I need the perpendicular slope. Remember my symbol for perpendicular is an upside down capital T? So my perpendicular slope here will be negative 4/3. It's the reciprocal and it's also the opposite reciprocal, so it has to be negative. So I'm going to use negative 4/3 and the point 1, 8. And I'm going to use that in the equation of y minus y1 equals m times x minus x1. And I write this equation over and over and over again so that I commit it to memory. I have it memorized. The more you write it, the better chances you will have of memorizing it as well. So now let's plug in our points. So y minus 8 is equal to negative 4/3, parentheses, x minus 1. Let's distribute. So y minus 8 equals negative 4/3 x. Negative 4/3 times negative 1 is positive 4/3. Make sure you're careful with your signs. I'm going to add 8. Adding 8 over 1 is the same thing as adding 8 times 4 is 32 over 4. Okay, we just found a common denominator for the fraction. So y is going to equal negative 4/3 x plus, okay, oops, that's not right because I didn't need 42. I didn't need 4, so I need thirds. So let's go back here and multiply this by 3 instead of 2. So 8 over 1 is the same as, multiplied by 3, 24 over 3. Okay, because 8 times 3 is 24. So 8 over 1 is the same as 24 over 3. 24 plus 4 is 28/3. I tend to leave my equations in improper fraction form. But if you had to graph it, you would probably have to put the 28/3 as a mixed number, so you'd graph it up properly. Right? I don't care if you leave it as an improper fraction or a proper fraction, but you can't change it to a decimal because it's not an exact answer, and you tend not to have it equations that have contained both decimals and fractions in them. They either convert everything to fractions or everything to decimals. Let's do one more. Oops, down here. There it is. So write an equation for the line that contains the point 3, 2 and is perpendicular to 2x plus y equals negative 4. And we're going to write this line in slope-intercept form. Okay. If you're not sure, always write it in slope-intercept form because that's the most universal form that there is. So when in doubt, write it in slope-intercept form. Now the equation 2x plus y equals negative 4 is not written in y equals form, so we need to write it in y equals form by subtracting the 2x from both sides. So y equals negative 2x minus 4. So the slope for that line is negative 2, making my perpendicular slope, remember that's negative 2 over 1, the perpendicular slope will be positive 1/2, because they have to be opposites of each other. So if one's negative, the other one's positive, and they have to be reciprocals. So now I'm going to use the point, I'm going to use the slope of 1/2 and the point 3, 2 to write my equation. Y minus y1 is equal to m times x minus x1. Y minus 2 is equal to 1/2 parentheses x minus 3. So distribute. Y minus 2 equals 1/2 x minus 3/2. Add 2. Adding 2 is the same thing as adding 4/2. Okay, 2 over 1 is the same thing as saying 4 over 2. So I add 4 over 2 just because it's easier for me to add my fractions when I have a common denominator. So y is going to equal 1/2 x. Negative 3/2 plus 4/2 is positive 1/2. The last thing we can do is look at a real-world situation, solving a real-world problem. Carla is using a coordinate grid to make a map of her hometown. She plots Main Street as shown. If 3rd Street is perpendicular to Main Street at the point 5, 7, what is an equation for 3rd Street? And put the equation in slope-intercept form. So we can see where Main Street is. It's this nice little black line on our graph, but we don't have the equation to it. And you might say, well, how in the world are we supposed to write an equation if we don't have the equation of the original point, of the original line? Well, we don't need the equation of the original line if we have the graph. We do, however, need to figure out the slope. So if I was going to look at 2 points, I'm going to look at this point here. And it looks like this point here is a logical point to go to. So if I go from this point here If you count, we'll notice it goes every other line, which means they're counting by ones because it goes 0 and then skips a line and then goes 2. So this would be 1 and this would be 3. So this is 8. Going down, you're going down 1, and to the right 1, 2, 3, 4, 5. So if you're going down 1 and to the right 5, your slope is negative 1/5. So my slope of Main Street has a slope of negative 1/5, which means 3rd Street should have a slope of 5, or 5 over 1. So now I have a slope, because I need a perpendicular slope. Okay, so the perpendicular slope to negative 1/5 is 5. So now I can use the slope of 5 and the point 57 to write the equation for 3rd Street. So y minus y1 equals m times x minus x1. Y minus 7 is equal to 5 parentheses x minus 5. Y minus 7 equals 5x minus 25. Add 7. Y equals 5x, and negative 25 plus 7 is negative 18. So y equals 5x minus 18. So the equation of 3rd Street is y equals 5x minus 18. All right, let's look at our closure question for today. If two lines are neither parallel nor perpendicular, what two statements can you make about the slopes of their lines? Okay. What two statements can you make about the slopes of the lines of equations that are neither parallel nor perpendicular? Please write out your answer to that as your closure question.